Presidential administrations, for as long as I can remember, have always had an interest in exploration of planet Mars. We move closer and closer every year. We are on the cusp with developments of new launch capabilities that we really do have the capability to throw large amounts of equipment at the planet Mars. We're also at the ability where humans can operate more autonomously from Earth, and they'll need to. Jim Pawelczyk. I'm an associate professor of physiology and kinesiology. The National Academies has released a new report, and this report defines the science objectives for the exploration of Mars. It's unique in the history of spaceflight research in that it marries up elements of the space science enterprise at NASA, but also the human exploration side of the house. So we're looking at changes to humans over the long term on another planet, as well as studying the planet Mars itself. The steering committee included 2 astronauts, myself and Tony Antonelli, and given our experience both as astronauts and as scientists, we bring a unique perspective on how to leverage the capabilities of the big apes, the humans, in order to execute a science agenda that is robust and can be done more quickly and more thoroughly than we can do with only robots. We expect there will be huge autonomy assists as well. And so you really need to start to think about the concept of human agent teaming as we look at future planetary exploration. We refined 11 priority science objectives. They include things that happen to human beings or to animals or plants on the Martian surface, an environment that has only 3/8 the gravitational field of our own, and also the evolution of the planet Mars itself. And of course, preeminent among those goals is the search for water, because with water, we always have found life. So life is sort of a backdrop that exists in many of the science goals. There's a lot of reasons why you would want to look at Mars. First of all, Mars is instructive for how the Earth evolves itself. So from Mars, we learn about Earth. We, of course, are humans. We are explorers. We're always curious about what is the next thing coming. And along with that, how does it work? The scientific exploration of Mars then is just wed to our nature of human explorers. Certainly, the exploration of Mars will be one of those moments that captures a generation, if not a century. And we want to maximize our understanding at that time. Mars has an atmosphere. Mars no longer has the liquid core like a planet Earth. That has changed its planetary dynamics immensely. All of that is of important study. NASA takes this approach as they call it architecting from the right. We begin with the goal in mind, and from that we back out the technologies or the equipment that are necessary to achieve those goals. And then we look for synergies, so areas, different science objectives that might rely on a common strategy. For example, if you're a geologist, drilling is important. If you're a biologist, drilling also becomes important from the standpoint of life detection. And then we also marry that to a moon to Mars strategy. So our approach now in the nearer term to exploring moon will be looking at what types of technologies then can be reutilized when we go on to explore Mars in the future. Setting the science objectives early is important because, again, the technology that must be developed then, those become the pacing items to when we explore. Ultimately, when we explore, that's a national priority. It's how we decide and how we're going to devote our resources. It's not going to be tomorrow. It will be many years, if not decades in the future. So people always ask, why do we have to go and explore and why do we have to do science? Science and exploration have always been hand in glove. If you look back in early 1800s, Thomas Jefferson's charge to Meriwether Lewis for the Lewis and Clark expedition, it included a full science agenda, studying the local flora and fauna, studying the topography, the geology, the weather, the composition of soils. These are all the same kinds of things that we're talking about for the planet Mars. So it's not that we're doing something new, we're doing something very old and very consistent, but in a very modern way on another planet.